Hi, friends, and welcome to this week's What's the Math Wednesday, where I pick a math topic and then go through examples, explain everything, and then give you practice problems. If you want to do them, awesome. If you don't, that's awesome too. As always, if you have any specific topics you'd like me to explain, or if you'd like me to delve further into one of these explanations or you do problems, please let me know. So last week we started law of signs. And I told you that this week I was going to do the ambiguous case. Now, this is an ambiguous case because when you're provided with two sides and a non-included angle, it does not adhere to triangle rigidity, which means that it does not always form one exact triangle, which is why these problems are more challenging. Because there are times when these problems, you can have no triangles formed, or you can have one or two triangles formed. Today, I'm going to talk about when you're provided with two sides and an obtuse angle. And again, it's a non-included angle, which basically just means the angle isn't directly in between the two sides. Okay, so reminding you, this is the formula for law of sines. It's the sine of an angle over the value of the side opposite of it, basically, is equal to the sine of a different angle over the length of the side opposite of that. And like I said in last week's, it's an extended ratio, which means that there's three ratios because you don't know which pair of items they're going to give you. So this is the textbook formula for it. But when you solve these problems, you're only going to have two ratios equal to each other. Okay, so law of signs. We are talking today about the ambiguous case, which is when you are provided with two side lengths and one angle measure, and the angle is non-included. And today we are talking about when that angle is obtuse. Now, next week we'll talk about what to do when the angle is acute. That's just a more challenging approach. And I didn't want this video to be super, super long, so that's why I split it up. So when an angle is obtuse in these types of problems, you're either going to have a problem that has no solution because no triangle is formed, or you're going to have a problem where only one triangle is formed. So it's either going to be information supports having one triangle formed and you can get an answer, or the information supports no triangle being formed because it's impossible given the information. So this is why this happens. Now, we know that in triangles, the largest angle will be opposite of the largest side, and as well, the smallest angle will be opposite of the smallest side, and vice versa. So if you have a triangle that has an obtuse angle, and the side opposite of that obtuse angle is equal to the other side provided or smaller than the other side provided, then it does not form a triangle, which would mean that there's no answer to these problems. Because what would happen then is the triangle would have to be like over 180 degrees, and that wouldn't work. You can't have an obtuse triangle that's isosceles. That doesn't work like that. And you can't have an obtuse triangle where the side opposite of the largest angle is smaller than another side. That's why if you're provided with that information, you can automatically say that there's no answer to that problem because no triangle is formed. So what we're looking for is the side opposite of the obtuse angle is larger than the other side. And if that happens, then only one triangle is formed. So here's example one. This is a Kutasoftware problem. Some of these I made up. Some of these I grabbed from other sources like Kutasoftware or deltamath. So in this case, they tell us that angle A, sorry, that's my phone, guys. Here we go. Angle A is 131 degrees. The side opposite of angle A, which is notated by lowercase a here, is 25 yards, and lowercase c, which is the side opposite of angle C, is 8 yards. So checking for ourselves. Is the side opposite of the obtuse angle the larger of the two sides that they gave us? Yes, it is. So that means that this forms one triangle. Here's the picture of it. I would always recommend drawing these pictures. I think it'll be much easier to approach these problems if you draw them. So angle A is 131. Side opposite of angle A is 25. Side opposite of angle C is 8. Like I said, that means that this has one triangle that's formed, so we can actually solve this problem. So we go into it. We set up using the law of sines. So the sine of 131 over 25 equals the sine of angle C over 8. Now, just interjecting here, typically what you'll see with these problems is they'll tell you to solve the triangle, which basically means anything that doesn't have a value you would solve for. For this example and for any example here, we're just going to solve for the missing angle. Because once you solve for the missing angle, you can solve for everything else in the picture. So I use cross products here. So 8 times the sine of 131 is equal to 25 times the sine of angle C. I want to isolate the sine of C. So I divide both sides by 25. So I get 8 sine of 131 over 25. And then remember, we're solving for an angle measure. So when you're solving for angle measures, you have to use inverse trigonometry. So because it says sine of C equals and then blah, 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 we would do inverse of sine and then the ratio. So the inverse sine of, and the ratio is 8 sine of 131 over 25. And you would plug that into your calculator and you would get approximately 25.0876 degrees. Now, I mean, it depends on how they want you to round. My recommendation is this: when you are using rounded values to find other rounded values, so like say you use this angle to find angle B now, because like we know that triangles are a sum of 180, I would keep the angle measure as 25.0876, just because the more decimals you have, the closest to the actual value it is. But you would want to see, like if you're doing this in class, you would want to see what your teacher recommends you rounding it to. So like if they said, oh, round to the nearest degree, it would be 25 degrees. If they said round to the nearest tenth, it'd be 25.1 degrees. So just play it by ear and see what your teacher wants. Okay, example 2, this is a deltamath problem. If you guys have never used deltamath, it is amazing. It's kind of like IXL if you've ever used IXL. So they give you a problem, it's all online platform based, and then like you input your answer and they'll tell you if it's right or wrong. They'll show you how to correctly solve. It's really an awesome, awesome platform. So here they tell you in triangle XYZ, lowercase z, which is the side opposite of angle Z, equals 6.4 inches. Lowercase y, which is the side opposite of angle y, is 6.2 inches, and the measure of angle y is 109 degrees. And they want us to find all possible values of angle Z to the nearest tenth of a degree. Okay, so this problem should say, like in your brain, you should be like, oh, wait, something's up with this. And here's why. If you were to draw this, right? Angle Y is the obtuse angle because it's 109 degrees. The side opposite of angle Y is 6.2, whereas the side opposite of angle Z is 6.4. So that's larger than the side that's opposite of the obtuse angle. And therefore, no triangles are formed because that's not possible. You can't have a side larger than the side opposite of the obtuse angle. That's not possible. So no triangles are formed. That's all you would say. You would say this is impossible, and you would go on to the next problem. So example 3, which I made up in my brain, says in triangle ABC, A equals 10 inches, B equals 10 inches, and the measure of angle A is equal to 105 degrees. Find all possible values of angle B to the nearest tenth of a degree. Okay, so if you draw this, this is what it would look like. And this is, again, is where you would say, this isn't right. Also, this information isn't right. I mistyped it. If you look, A is 100 in the picture, but 105 in the problem. So I'm sorry about that. But again, you can't have an obtuse triangle be isosceles, because if you recall the rules of isosceles triangles, the angles opposite of the congruent sides are also congruent. So it has two congruent base angles and two congruent legs. So that would mean that this triangle, angle B, would also be 100 degrees or 105, however, like whichever one you want to work with. And that would make this triangle go over 180 degrees. So as a result, no triangles are formed with this problem. This is an impossible problem, and you wouldn't need to solve this anymore because, again, you cannot have an isosceles obtuse triangle. It doesn't work that way. All right, so I hope these examples were good for you guys. I'm just going to show you the UDO problems. Again, you can do them. You don't have to do them. I'll do another video to show you how I got my answers. And as always, if you want me to further explain something, just let me know. So here we go. UDO number 1 asks you to solve for the measure of angle A and round to the nearest tenth. So again, I'm just going to read this out loud just in case. The measure of angle B is 97 degrees, lowercase a is 23, and lowercase b is 23. UDO 2, again, solve for the measure of angle A, round to the nearest tenth. Excuse me. The measure of angle B is 117, lowercase a is 16, and lowercase b is 38. And then UDO number 3, our last problem. Solve for the measure of angle A, round to the nearest tenth. The measure of angle B is 150 degrees. Lowercase a is 50, and lowercase b is 48. So have a great day, guys, or a great evening. And yeah, I will see you later with answers. Next week, we're going to talk about these problems with acute angles. Bye.